Welcome. Yesterday we went through some notes and we talked briefly about free body diagrams, which we'll call the FBD. Today we're going to really dive into them more intensely. So let's hit a quick review. At the same time, please pull out page 2 of your packet because we'll start with there. Now, this is just a little review to help us get started again and remind us about free body diagrams. So these are used again to show the forces, and normally we don't put a number to them. Again, the size of the arrow will indicate how big the magnitude or the number. So my example, if we're going 5 to the left and 10 to the right, the arrow to the right would be twice as big as the arrow to the left. And then we're going to simplify things as boxes. You could get crazy with it. Mr. Foss is not a good artist, so I won't. Here is an example of one, and the couple of the forces that we talked about. Again, this was in our notes before. You have a normal force, or you could have a normal force pushing up. Gravity is always there pushing down unless it says neglect gravity, which is rare. Friction force, the one on this picture pointing to the left, is the one that opposes the motion, and F applied, or the friction applied, that's what you're applying to. I always think about me pushing on something. Now, here are our 5 forces that we're going to do. Right now would be a great time to stop the video, go to page 2, and those are the first 5 that are up there. So make sure that you get all those. They're not in correct order. The first one is applied, then air resistance, gravity, friction, and normal force. So take a second, pause the video, write those down on the top of page 2. All right, welcome back. What I would like to do now is, hopefully you've got those up there. I'm going to go through a couple of them. So let me stop sharing here and I'll start sharing again to get the correct one. All right. So here is our free body diagrams page. Hopefully you have already entered what the applied force is, the air resistance, and so forth. So I'm going to scroll this up a little bit, and we're going to look at number 2. So, all right. So a football originally kicked at a 40-degree angle to the horizon is at its peak of trajectory, ignore air resistance. Well, if we think about it, we've kicked this football and it's going up, and then it's eventually going to come back down, but it's at the peak of its trajectory, so it's at the top. Now here, if it's right at the peak at this instant, we have to know what forces are dealing with it. And again, here is ignore air resistance, so we don't have to do that force. Now, I'm going to draw just the box. The box is symbolizing the football, and we really got to think about what is going on here. At this point, there is no greater force left to right, so we're going to keep this one easy. What's the only force that's applied on it right now? And it's pushing down. And what pushes down all the time but the force of gravity? I'm not going to write out gravity, I'll just do the F of G. So there's the force of gravity. Now, you probably, if you wanted to get deeper into physics, you could, but I like this answer right there. You could say that it has an applied force and some sort of air resistance this way. But again, we ignored air resistance, so we really don't need those two. That right there is our free body diagram for that one. So once again, Couple distractors in there. 40 degrees really doesn't have anything to do with it just at that moment. So the only thing is gravity's pushing it down. Let's look at number 3. A rightward moving car is skidding to a stop across a level road with locked wheels. And again, we're going to ignore some air resistance here. Sometimes it's nice to draw a picture maybe on the side to understand what's going on. So if you need to, you can draw your little car. Here's my car with 2 wheels. I'm going to give myself an arrow moving right. That's not a perfect picture of a car, but gives me an idea when I look at it. But when we draw free body diagrams, we normally use a box for whatever object it is. So there's our car. Now, again, we only have 5 different forms of friction, and we can already take away air resistance because it says ignore it. So you can start with any one you want. I like myself gravity because gravity is always there. I know I have to put that down. So that's the force of gravity. Now, I always like to do the force opposite of it to know if it's balanced or not. And the force pushing up, so the car doesn't go into the earth, is called our normal force. And you can think to yourself, is it flying up in the air or going down into the ground? It's not. This is a balanced force, so the arrows should be just about the same size. So there's my force, normal. Now, this is the trickier part. What is it talking about? We are skidding to a stop. Well, what do we have here then? It's trying to stop. So we have the force of friction, and not in the rightward, but in the leftward way. And we're going to put F of F there for me. That would be the force of friction. So a lot of people want to put that applied to the right, but in here we're skidding to a stop, so it's the accelerating to the right. All right. At this point, I'd like you to try the rest of them. So you can pause the video. Like on the other one video, I'm going to go through and answer all of them as we go. So again, pause, try to do them, come back, see if you get the same answer I do. Welcome back. Hopefully you tried a couple. Maybe you got stuck, but you tried and see what you got. So let us go here and start with number 4. Here's our football again. It is moving upward and to the right toward the peak of its trajectory. Ignore air resistance. Well, truth be told, this is just like the first one. It is going up and to the right, but it's not accelerating in either direction. So we can simply put the force of gravity. Again, because we're ignoring the air resistance as it goes through. So again, a little bit tricky of the words. We're going to think about what force is going on at the time. And here we're ignoring air resistance, so we're not moving. Number 5, a downward moving skydiver is falling at constant velocity. Now that word is pretty important right there, constant velocity. And we're moving downward. Again, we can draw our box, that's our skydiver. And what force do we always have? You got it. We got the force of gravity. Now, this would mean we're always accelerating toward the ground because there's nothing else. But there's that key word again, constant, which means you're moving, but it's at the same speed. And remember, these vectors are accelerations. So I'm going to draw it in a different color just so we can see it a little bit. But this would be a force up. Now the arrows should be just about the same. And why is this one constant speed different than the other ones? Notice that the one above, we talked about ignoring air resistance. Well, here we cannot ignore air resistance. So this would be the friction of air resistance. So this skydiver is falling, same speed, he's not accelerating. Those arrows should be the same. In physics, because our drawings aren't awesome, if we want people to know that the arrows are the same, sometimes we do this. We'll do a 1 tick mark on each arrow. So 1 tick mark means that it's the same on every one that has a 1 tick mark. If we think they're different, we could do one with 2 ticks and one with 1, and that would show that they're different. All right, let us try number 6. A hockey puck glides to the right across ice at a constant speed. Ignore air resistance. Well, so we can draw our hockey puck, which is a box. Again, we will always have our friction force of gravity. Now, again, it's not going directly into the ground, so there's got to be something else with it. We have that force, and now it's on the ground, so it can't be air resistance. This is our normal force. And again, it's not going either way, so if you wanted to, we could put little tick marks. Because my drawings aren't awesome, that shows that both of those are in the same one. Now, last but not least, you could probably leave it like this, but let's get into this a little bit more. It's sliding across to the right, but what's the key word here? Constant speed. So we probably had some sort of force applied, but we also have some sort of friction, not very much, it's on ice. So I'm gonna say friction here. Now, the really key point is a constant speed. So I'm gonna say that these 2 arrows, you can show, I show by the 2 tick marks, are the same. All right, there I did 3 more. Take a second, look at them, see if you have any questions with those. And then try 7, 8, what does it go up to? Let's go 7, 8, 9, and then come back to the video. All right, welcome back. Here are 7, 8, and 9. I'm gonna go a little quicker through them. Hopefully we got a little better understanding. These free body diagrams, you think that they're like easy. There's only 4 forces, but it's kind of hard to think through them. So here we go, let's try it again. A softball player dives head first and is sliding across the infield dirt. Keyword, ignoring air resistance. So again, we're going to just draw the box. What force do we always have? We have the force of gravity, and our softball player is not like falling into the earth, into the dirt farther in. So there is that earth is pushing back up a little bit, and that's our normal force. Now, we're sliding across to the right. We have to have some sort of thing. And think if you're in there, you're actually slowing down, right? You're not just speeding up as you're sliding on the dirt. You're slowing down. So we're accelerating in the opposite direction. And it says it's going to the right. So we're going to have a force of friction to the left. Again, they're not the direction of where we're going. They're the acceleration. So there is number 7. Okay, number 8. A rightward force is applied to the dresser. Ooh, there's a big key word right there, huh? Applied. So we know we're going to use our applied force. To the dresser to accelerate it to the right across the bedroom. floor. Ignore air resistance. So a lot of key words in there that are important. Let's begin with, I feel, the easiest ones to do. Again, there's our dresser. And we always have gravity. And this isn't falling, it's stationary. So something's got to also push it up, and it's not flying into the air. So these two forces, and that's the normal force, are the same. They're accelerating as fast down as the same as they're accelerating up. Now, we're sliding this across the floor to the right. And do you see that key word there? Accelerate. So that means that the movement to the right, which is our applied force, must be bigger than our friction force. So I made that arrow nice and big, and then this one is our force of friction on the left. Again, sorry for the writing. It's hard to write on the screen, but is much smaller. If your drawing is not super awesome and those arrows are close to the same size, do this. Put a tick mark there and 2 tick marks there. That shows that that applied force is much stronger than the other one. Okay. Very similar question if you look at number 8 and number 9. A couple key differences. Let's look at it. A rightward force is applied to a crate to push it across the floor at constant speed. Well, our crate and our dresser are just about the same. So again, we just draw a little box. And again, Mr. Foss loves the gravity and normal force because that's there. Nothing's pushing it down or pushing it up. Now, very similar to number 8, but constant speed. What does that mean with our accelerations? Well, we were pushing it to the right, so that's our applied force. And there are friction to the left. So there's my friction force. Now, my arrows are pretty close to the same, so I'd consider them the same. But if your drawings are a little sloppy like mine, we may just put in 1 tick mark there, and that shows both of those are the same. So it can be pushed across the floor. It's just not accelerating the constant speed. So it's still moving in a constant speed. All right. Now we have 10 and 11 next. So I'm going to clear it. Take some time if you want to try these. Maybe you stumbled a little bit, need a little bit more help. Maybe you can get 10 and 11 by yourself. All right, welcome back. Let's finish these up. Obviously, you can look down here, number 12. You can make up your own diagram on there. But a sledder has reached the bottom of the hill and is coasting to the right while slowing down along a loosely packed snow, again, ignoring air resistance. Excuse me. A couple key things here. We're going down a hill, great. We're coasting to the right while slowing down. That means we are accelerating in the opposite direction. So here's our sled. Again, Mr. Foss loves the force of gravity and the normal force. We're not flying into the air. We're not going into the earth. Now, we're slowing down. And again, these arrows are accelerations, not speed, but accelerating. So if we're slowing down and our movement was to the right, that means we are accelerating to the left. And what type of force is this? You've got it. It is the friction force. So, all right, last one. A downward moving skydiver who has just opened the parachute is slowing down. Again, we think about our acceleration. So that's accelerating in one direction. Let's think about it. Diagram the forces on the skydiver / parachute combination. Again, we don't need to draw that person. We just do it as a box. No movement left or right, it talks about. But again, we know we have gravity pushing down. That's the force of gravity. And now we got to consider slowing down. And that means we're not accelerating faster to the ground. So what is going on here? Our air resistance, or arrow up in this case, because it's not a normal force, because we're not on the ground. This would be air resistance. Should be a little bit bigger there because we're slowing down. So you could probably tell by my arrows, but let's do a little tick there and 2 ticks there. All right, so that is pages 2 and 3. You should have pages, start with those definitions in front, and you should be done with pages 2, 3, 4, and 5 as of right now. Again, if you need to go back, look at the video, but these pages should be complete. All right, thanks guys, we'll see you soon.